Hello and welcome to session 14 of the MMO development class. So today we are going to be kicking off where we left off with ANTLR and CGS. So last week we left off with a fairly complete grammar. Our grammar seems to, our combined grammar, which includes a parser and a lexer, seems to be producing the kind of trees that are going to be easy to parse using a tree grammar. So today what we're going to do is we're going to get the tree grammar, or the output of our parse, or not our parse tree, but our AST, and parse it with a tree grammar and get the output into some sort of in-memory representation of what a selector, a rule, and a list of properties actually are. So I'm going to go ahead and jump into this, launch up my ANTLR file watcher program, and I'll just put that up here off screen so I can keep track of it as we work on our tree grammar. So I've talked about tree grammars before a little bit, and what they are is they're grammars that allow us to parse trees. And the input to them is basically the output of our combined grammar. So it makes it very easy for us to look at our rules, our rewrite rules, like for example right here, that takes a stream of tokens and turns it into an actual tree structure. Tree grammars make it very easy to parse out this tree structure and then do something with them. Now, what something is going to be highly dependent on what exactly you're trying to, what problem you're trying to solve. In this case, what I want to do is, I want to get this out of the way, kind of. Go away. Hurry up. There you go. What I want to do is, I want to write in what are called actions, and we see an example of an action right here. An action is really anything that starts with those curly braces that isn't a predicate, and so the syntax is a little bit ambiguous with what a predicate is. We're not going to be worrying about those right now. I believe we did use one actually to detect a descendant versus immediate descendant relationship. So we used a little predicate right there where it is a block of C# code, but it's preceded by a, or there's a question mark afterwards, which means that this alternative is only going to execute if this block of C# code evaluates to true, kind of like an if statement. But if you don't have the question mark in front of it, what happens is the ANTLR parser, or the ANTLR compiler, will actually go ahead and inject this bit of C# code straight up into the grammar, and that's exactly what we want. We basically have a recursive descent parser that we can inject little bits of code here and there to do something. Again, that doing something is dependent on what you're trying to do. So let's see here. How are we going to do this? Well, we need, first of all, we need some interfaces. We need some interfaces that are available to our compiler project. Basically, the way that this is going to work is, I'm going to go ahead and, well, the first thing is I'm going to go ahead and actually go about writing the basic structure of my tree grammar. And the way that's going to work, there's a very easy way to do this. Basically, anything that's matched, or these outputs, is actually in the same syntax as a tree grammar's input, if that makes sense. So an easy way to get a tree grammar going is to take all of your combined grammar rules, which I'm going to do right here, at least for the parser, and I'm going to cut them and I'm going to paste them right into my tree grammar. But that's not all I have to do. I have to go in and I have to basically remove everything before each one of our rewrites. And what I'll be left with is a very handy little tree grammar where I can start putting in some stuff into. So relationship can be a descendant, or it can be an immediate descendant, for example. And our pseudo selector turns into just a pseudo selector token. We remove the constructor parameters from our token instantiations. I copied and pasted that code, by the way. Class selector just becomes a class selector. ID selector just becomes a match for an ID selector. I have to strip out all of the constructors for my tokens, like I said before. Element selector just becomes an element selector. Values remain how they are. Resources just become a resource token. RGB colors just become an RGB token. And RGBA colors just become an RGBA token. Except for actually what I need to do is, instead of doing this, I need to do the opposite of this. So you can think of what I'm doing like I'm going through and I'm inverting the output of my combined grammar into the input of my tree grammar. Now, I'm not going to leave it like this. I can clean it up a little bit and make it a little bit easier to read, but this is just a really good little starting point for us. Okay, so now I have a tree grammar that seems to fail to compile. What's wrong with that? It really doesn't like no output object. Token reference resource may not have parameters. What are you yelling at? Oop, I forgot my to strip out the constructor right there. Alright, rewrite syntax or operator with no output option. Rewrite syntax. So it looks like I forgot to remove one of my rewrite bits. And I think that could be from this. See, I have this comma with the bang right there. Well, that just means that that's a rewrite rule that I don't want. And hey, look, now I have a tree grammar. So if I look at my generated tree right now, what I'll have is a recursive descent parser that understands the output of my combined grammar parser. So that's exactly what I want. But we can do a little bit better than this. Right now it looks kind of ugly. So let's go ahead and see about cleaning our tree grammar up just a tiny little bit and stuffing things. So let's see here. So what's a selector? Selector is a selector followed by selector type followed by optional pseudo selectors followed by child selectors. I like that. Actually, the more I'm thinking about this, the more I don't actually care about breaking this up. Maybe I can do a little bit better on my values. Maybe I can make that look a little prettier. You know what? I just realized something. Now that I'm looking at this, what I need to do is a value can be, let's break up this code a little bit to make it easier to read. A resource, an RGB color, an RGBA color, a color hash, or a numeric value. I'll keep it like that, but I just realized something I forgot. In CSS, and obviously CGS, because CGS is built to be like CSS, we can actually have multiple values for a property. So let me write a test that'll show everybody what I mean by that. So let's go ahead and do that. I'll do a test, public void, multiple values on property. And what do I mean by that? Well, let's say we have parse CGS dot class selector of test with a margin of 0px, 5px, 10px, 2px. Now that's completely valid CSS and it's a valid CGS, but I don't think I handled this case quite yet. So let's see if I can go ahead and get this to work. The result of this should be a rule followed by a selector, followed by a class selector with the value of test, and then it should have a single property of margin, but margin should have a 0px, 5px, a 10px, and a 2px. Now let's see what happens when I run this test. It's probably going to fail. Oh, hold on, I don't think I added it to my session. There we go. Mismatched input 5 expected semi. So that's because it's only parsing one value out of this. So to fix this, what I could go ahead and do is I need to do a couple things actually. Unfortunately, the way that I have my values working right now, you'll notice that they aren't actually being tied together in the tree with their unit. And what I mean by that is, look how margin left is just 10 space px. That means this tree structure I'm looking at right now is a margin left with the sibling of 10 and the sibling of px. And that's not what I want. I actually want to modify my grammar a little bit so values are contained within themselves, just like how we have RGBs right here. See how RGBs and RGBAs are contained within themselves? I need to do the same thing for numeric values. So for example, this 0 would become that, and this 10px would become that, this negative 10px would become this, and so on, because we need to... Actually, I could do something even better than this. You guys want to see a magic trick? What I'm going to do is I'm going to remove the concept of my units being attached or added into my stream as a separate token. Instead, what I want to do is I want to combine the token value and the token type, and then have the text of the numeric value be the text of the token. Which means now that I've done that, many of my tests are going to fail. So let's go ahead and fix those tests. If I jump back into my combined grammar right here, what I can do is I can go down here, I can find my value. My value has a ident, resource, RBGA, blah, 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 or number value. That's what I care about. A number value is number followed by pixels or points or percent. So let's go ahead and write this in a way that it'll combine them together. So let's see, how can we do that? So we can either have a number followed by pixels, points, or percents, or we can just have a number. So what I'm doing is I'm writing two alternatives. One of them is going to do nothing. It's just going to turn into a number. The other one is going to turn into something depending on if it's a pixel, point, or percent. So the way I'm going to write this grammar is I'm going to say number with pixels, or number with points, or number with percent. And then I'm going to use the awesome syntax or grammar rewriting rule to go ahead and say, okay, I want to turn a number and a percent into just a percent token that has the text of the number. So now I'm adding some semantics to those numbers so I can parse them easier in my tree. So pixels becomes that and points becomes that. Alrighty, it's compiled, so let's run again and see what happens. Awesome. Not awesome. I just broke multi-line comments and multi-line comments, and I broke single-line comments. Oh, that's because I forgot to fix the actual tests. Derp. But see, this is why unit testing is amazing for stuff like this. Awesome. So the last thing I need to do is now I need to fix my multiple values on property. So what I want to happen is I want my tree to look like this, 0, 5, 10, 2, because that's exactly what I have right there. So to do that, I'm going to go into my combined grammar. I'm going to find where my value rule is. I know it's somewhere in here. Value. And then find where my value is being used by, which I believe is going to be the declaration. And a value, instead of this, what it's going to be is it's going to be value one to many. Oh, hold on, I think I hit the run button too quick. Sweet. So we're getting a little bit closer. Now what are we missing? Ooh, I misspelled. On my test, I did select and not selector. Awesome. So now we can have multiple prop values on a single property. Let's make this a little bit more interesting. So let's see here. I'm going to write another multiple values on property, and I'm going to do it a little bit different. I'm going to throw in an ident. So how about ble as an identifier? I'll toss in a resource of wo.png. I'll toss in a pixel value, a percent value, a straight up numeric value with a decimal, and a negative numeric value with points. And then what else can we do? I can toss in a color hash. What do color hashes look like again? Okay, that's what they look like. Okay. So let's see if this will work. Well, it's going to be font is going to be the name of the property, followed by an identifier of ble, a resource of wo.png, 10 for 0.43, -2, and then E. So I believe what that's going to be. And let's make sure this actually ran. And hey, look, it works. So we're parsing the input and changing it to a format we'd rather have it in so we can parse it again and interpret the CGS rules. Exactly. That's exactly what we're doing. We're taking our token stream, we're parsing it with our combined grammar, we're rewriting it into a tree, and then we're using a tree grammar to parse the tree. And it makes the code a lot cleaner, and it also makes the code very reusable, because now we don't have our grammar right here coupled to the concept of CGS. We can use the output of this grammar to do anything we want. And then our tree grammar is going to be very clean and easy to understand and easy to modify as we move forward. Okay, so I have to modify my tree grammar actually because I changed the way my numbers worked. I'm going to remove my number value rule. Instead, I'm going to match a number, a pixels, which if you remember is a number, a percent, or a points. So that's what I'm going to match with my value. The second thing I need to do is I need to go up here and find where my values are and say we want to match one-to-many values. Okay, so I think that pretty much gets our tree grammar where I want it to be for now. So let's back up. How is the tree grammar going to work? Well, so when we enter a rule, I mean, is mostly everyone familiar with recursive descent parsers? They're typically the kind of parsers you would write by hand. So you would say, okay, look at the current token. Is it a... Well, I can just write some pseudocode out, because this is the kind of parser that ANTLR generates. So I could say, I don't know, if token is ident, then... Well, that's not good. If token is keyword function, then parse function. Else if token is keyword class, then parse class. And then parse function would look like, okay, parse block. And a parse block, or it would look like something like parse signature and parse block. A parse block would be like expect open semicolon or open curly parse while true parse statement, or while next token does not equal this parse statement, and then expect that, and so on and so on. So a recursive descent parser, the whole idea is you have these little, what are called rules, which, well, in ANTLR they're called rules, and they allow you to recursively descend from a general function into a specific function. So at the top level, we might say, okay, are we looking at a function? Are we looking at a class? If we're looking at a function, jump into a function. What's a function? A function is a signature in a block. What's a block? Well, a block starts with a curly brace. While we don't hit another curly brace, we'll parse out a statement, and so on and so on and so on, until we get very specific things. And that's exactly how CGS, or how ANTLR builds its generators, or its parsers. So what I'm going to want to do is, let's do some fun stuff. So I'm going to add in a project called CGS.base. And CGS.base is going to contain the interfaces that my code or my tree is going to invoke, if that makes sense. So I'm going to add an abstract namespace. I've never seen anybody else who does that, but I do it and I find it to be nice. Let's build our builders. We need builders. So the first builder I'm going to add is an style sheet builder. And I forgot ER. Builder. And what's a style sheet builder going to do? Well, all a style sheet builder is going to do right now is have an style builder called create style. What's an style builder? Well, an style builder is going to be the object responsible for building out a style. So it's going to have basically two things. It's going to have an selector builder, create selector, then it's going to have a void set property for our properties, and they're going to have a name, and they're going to have an enumerable of value, called values. So what's a selector builder? Well, a selector builder is an interface that allows me to build a selector. And so what we're going to need is we're going to have void set class selector, string class, or how about class name so I can avoid that little guy right there. Set ID selector, string ID, set element selector. We'll have an element type right there. We'll have a set pseudo selector with the string pseudo, and then we'll have a push descendant, push immediate descendant. I hope I'm spelling descendant correctly. Nope. And then I want a push none, which we'll use for, you'll see where we'll use that. Okay, so what's an value? An value is just an abstraction over what a value is in our language. And this is where things get kind of fun. But for right now, all an value is going to contain is a value type. So we're going to have a value type, which unfortunately will clash with system.valueType. So I'm going to call this property value type. What's a property value type? Well, a property value type is going to be a enumeration that can be a resource, a string, a number, an identifier, or a color. And that's all that's going to be. And then what's an element type? An element type is just, again, a nice little basic value object we can use to refer to elements. So an element type is going to have a public constructor that takes in a type. It's going to look like this. And then I'm going to use ReSharper to generate its equality members. And come on, ReSharper, you can do better than that. Generate equality members. There we go. And then I'm also going to generate the formatting members, which is just going to return type. So a couple fancy little value types we can use to make things easier. So I'm going to tell ReSharper to move types into matching files. I'm going to move element type and property value type into another namespace called value objects. And then I'm going to fix my namespaces. And let's see what we have so far. So we have an iStyle sheet builder. An iStyle sheet builder allows us to create styles. A style allows us to create a selector or create multiple selectors and set properties on it. A selector allows us to set what kind of selector it is, and then it allows us to move forward on the chain. So the way we would use the selector builder would look something like this. sb.set. So if we had a style that had a selector that looked like h1.test, immediate descendant stuff with an ID, this selector would turn into this invocation. It would start with sb.set element selector new element type h1. Then it would be sb dot push none, and then sb dot set class selector test, then sb dot push immediate descendant, and then sb dot set id selector stuff. So does this usage kind of make sense? To construct a particular selector, or this selector right here, we would set the element selector, push none to say that we are adding another selector on top of it, but without any sort of descendants. Then we set the class selector of test, then we push an immediate descendant, which represents that, and then we set the ID selector. And then that's how we'll keep that information in. Okay, so that's how we'll interface with our interfaces. But what we need else, or what more that blah blah words, what else we need is our implementations of our I-values, because we need all of our different values created. We need resources, strings, numbers, identifiers, and colors. And we also need a way to actually build a style sheet from an iStyle sheet builder. So let's actually start off with, how am I going to do this? Let's start off with creating our values first. Then I'm going to write a bunch of tests to make sure that my iSelector builders, my iStyle builders, and my iStyle sheet builders are being used right. And then after that, we'll move on. So for my different types of resources, we need things like colors, we need identifiers, numbers, blah, blah, blah. We need a lot of stuff. Let's go ahead and write those out. Let's do resources first. So I'm going to create a class called a resource value. And what a resource value is going to be is it's going to be an I-value. It's going to have a type, which will always be return resource. Then inside of its constructor, we'll have a string resource path, which will look like this. And then I'll go ahead and put in my equality members. And I'll put in my formatting members. My formatting member is going to look like resource. There we go. So there's a resource value. What else do we have? We have strings. Strings are going to be very similar to this, honestly. String value. Actually, I could probably use inheritance to make this process a lot easier, but whatever. Alright, so what's a string? A string is just, it's a string. Not much more to say about it. What's it going to look like when we print it out? It's just going to look like that. We'll just make it a lot easier to debug by putting in these proper toStrings. Next up we got numbers. Numbers are going to be a little bit more complicated because not only do we need a number, but we also need a number unit. So it's a number value. Number value will implement iValue. For its type, it's going to return a number. We need another enumeration right now called number unit. And number units, we can have none, we can have pixels, we can have points, and we can have percent. So none, pixels, points, percent. Those are our number values we have. So number value takes in a value and it takes in a unit. Next up we need our equality members, which are just going to compare number and unit. And then finally we need our formatting. And our formatting is going to be a little funky. I'm actually just going to do the easy way on this one. Come on, keyboard, you're being a pain. Okay, so we have that. This is going to be value toString plus px. Points is going to be value pt. Percent is going to be value plus percent. And default, let's just throw a new argument out of range. So there we go, simple enough. Okay, so we have our number values, string values, resource values. Now we need identifier values. Those are going to be very easy. An identifier value is simply going to return identifier as its type, and it's going to take in a string value. There's not a whole lot else to say about this. Okay, now we get into something a little bit more complicated. And something that's going to be a little bit annoying to write. And that's our RGB, our color values. So, let's go ahead and get that over with. What's a color value? Well, a color value takes in an RGB and an A, or just an RGB. And those are all going to be integers, except for A, of course. So RGB, and then A is going to be a float. I'm going to create another constructor. This other constructor is going to take an RGB, and it's simply going to defer to the other constructor, passing RGB, passing in a value as for 1 as the alpha channel. Next up, we have our equality members, so I'll get that out of the way. We have our formatting members, again, very simple stuff. RGBA. Let's go ahead and make our... I'm trying to get my formatting members to print out something as close to CSS as possible to make it a lot easier to read. So this is the basics of my color value, but it gets a little bit more complicated than this, and that's because we have two other ways to create a color value. And that's from a named color, or from a hash color. So let's go ahead and implement the hash first. I'm going to implement a public static color value optional, or not optional, sorry, what am I thinking? The last code base had this as a structure. From hash, hash. Okay, so this is going to be fun. So I'm going to say if hash.length equals 3, else if hash.length equals 6, because those are the two things that we can support. And then if it's not 3 or 6, we'll return null. Next up, what if it's 3? Well, there's actually a very easy way to do this. What I'm going to do is I'm going to say int r equals new string hash at 0, 2. And then g equals new string hash at 1, 2. And then b equals new string hash at 2, 2. Now, the string constructor is something that not a lot of people use, surprisingly. Oops. What the string constructor allows you to do is it allows you to repeat a character for a specified count. So that's really handy. So that allows me to create my RGB strings by just repeating the values and the different bits of the hash. So that makes the code look a little bit nicer. Then what I'm going to do is I'm going to return a new color value with convert.to int 32. Now, guess what? If we pass in a string, we can pass in a base, and that makes things very easy, because if you guys recall our hash values, for example, FFF, this equals 255, 255, 255, which, fortunately, we're just looking at the hex values of these numbers. So all we need to know what to do, or all we need to know to work with this is how to convert from a hex string into a integer. And we can do that by passing in a parameter or argument into our convert to int32 method. So I'll convert r with the base of 16 to int32, convert g to 16, convert to int32, convert b into 16. So that makes things fairly straightforward. Next up, what we have to do is we have to handle it when it's the case of it being 6 characters long. Now, if it's 6 characters long, that means there's going to be a nibble for every single one of these bytes. So how's that code going to look? Well, it should look something like hash at 0 plus hash at 1. Ah, this is fun. I'm going to have to convert it into a string. There we go. And then g is going to be hash at 2 and 3, and b is going to be 4 and 5. What's the 2 in the string equals new? This repeats the character for X amount of times. So remember how, like, if I were to write the hash value for FD, this actually turns into 44FFDD. Okay, and the last thing is I wonder what happens when convert.toInt32, convert.toInt32. I wonder what happens if it can't convert. Does it throw an exception? I wonder. I honestly can't remember if it does. Let's see here. We have a convert int32 and 32 taking in a string, but none taking in a string in a base. Am I looking at the wrong version of .NET or something? Oh, here we go. It's at the bottom. Format exception. Value contains a character that is not a valid digit in the base specified. Okay, it does throw an exception. That's easy enough. There we go. Just eat it. No reason not to. I'm trying to make when designing languages like this, I want to make things as permissive as possible, and returning a null will make it so I can actually handle the error a little bit closer to the user interface of the code. I don't want to just halt execution if there's a problem converting. So, okay. There's one more thing that we're missing. We're not doing named colors. But honestly, I'm not going to worry about that right now. I'm not going to implement named colors. Or let's toss in black and white. That's easy enough to do, right? I'm going to create an enum called colors, and I'll toss in black and I'll toss in white. And then color value will have a constructor that takes in one of these named values. Black will just be R equals, actually this is unnecessary, they're going to be initialized to 0 anyway, it doesn't matter, but whatever. White is going to be 255 with an A of 1. Black, actually I'm just going to put A equals 1 up there because they all have A equals 1. And then on the default I'll just toss an exception, that makes enough sense. So there's black and white. I don't care about implementing the rest of the named colors. If you want to, I did before, and if you want to, you can go and look up the documentation on CSS for all the named colors, and they'll give you the RGB values for each. Okay, so we now have our resource types built and our builders built. So now we have to write tests that make sure that our tree grammar is invoking the appropriate methods on our builders. Now, yes, we could certainly go ahead and write out some, use some mocking framework or something, but instead, what I'm going to do is I'm going to create a actual implementation of all these guys, and I'm going to have it print themselves back out to a string so I know that they understood. You'll see what I'm saying in a second. Words. So, let's go ahead and create a namespace and call it builders. We need a, what do we need? We need a style sheet builder, which implements style sheet builder, which I have to reference. We need a style builder, style builder, which has those two, and we need a selector builder. Selector builder. Whoops, I made it an interface for some reason. There we go. Okay, so how are we going to be able to test this? Well, what we need to do is we need to test to make sure that our tree grammar is invoking the appropriate methods on all of these classes. So what I'm going to do is I'm going to, on my style sheet builder, which my style sheet builder is the root object inside my tree grammar, it's going to have a public string toDebug string method, and then it's going to have a private read-only list of style builders styles, which is going to be instantiated in the constructor, and then we're going to say var style builder equals new style builder, and then styles add style builder, and then return style builder. And then when we do .toDebug string on our little stubby mocky type class that we have right here, what I'm going to do is I'm just going to say return string.concat space styles.select toDebug string. Whoops. I want my styles to be of type style builders, not iStyle builders, because I want the toDebug string to go directly on the concrete class. Okay, so here's my toDebug string, and toDebug string should really return a string, not an object. So what's the toDebug string going to look like here? Well, we need a list of selectors and we need a list of properties. So I'm going to create a private list of selector builders, make it read-only, instantiate it in the constructor. Create selector, we'll just selector builder equals news, selector builders add, selector builder, return, selector builder. And then properties, I'm going to have a private read-only list of tuples of strings and IEnumerable of iValue. Hold on, somebody distracted me for a second. Go ahead and fix the spelling on that. Okay, when we set a property, all I'm going to do is I'm going to say properties.add name followed by, tuple.create name followed by values. And then when we do a .toDebug string, here's what we're going to return. We're going to return an open curly brace and a closed curly brace, and then inside of it we're going to put, this is going to get complicated. To escape these curlies. Okay. So actually we have 0 is going to be right here. That's going to be our selectors. This is going to be our properties, or these are going to be our properties. Our selectors is going to be simply string.join on a comma, and then I'm going to pass in selector builders.select toDebug string. So that's how our selectors are going to be printed out, and then our properties are going to be printed out by string.join on a semicolon, and then I'm going to pass in properties.select name value semicolon. Actually, I'm going to take the semicolon off the join and just separate them by spaces. And then that's going to be t.item1 and then t.item2. So basically, by invoking toDebug string on our objects or our builders, we'll get a very CSS-like representation of what was parsed out, which will make this very, very easy to test. So the last thing we have to do is our selector builder. We have to do a toDebug string. Now this is where things are going to get a little tricky. Here, what I'm going to do is I'm going to say private string debug string. I'm going to initialize debug string to blank. When we set a class selector, I'm going to append on, actually I can just use a, I know it's hardly going to make a performance difference, but why not, since I can. So when we set a class selector, we are going to do that. When we set an ID selector, we're going to append on this. When we do an element selector, we're going to actually just depend on type. When we do a pseudo selector, we're going to append on that and then that. When we push a descendant, we are going to add a space. When we push an immediate descendant, we are going to add that. And when we push none, we're going to do nothing. And then toDebug string is going to return that. So, easy enough. Let's go ahead and test our tests. Let's do tree parser tests. Test fixture, public, void, selector builder so we'll do style sheet, and then let's do rule 1 equals style sheet dot create style. Selector 1 will be rule 1 dot create selector. Hold on, let me indent this. It'll probably be a lot easier to there we go. Selector 1, let's go ahead and put set a class selector on test. And then selector 1 dot push none, selector 1 dot set ID selector whoa, selector 1 dot set pseudo selector blah, and then selector 1 dot push immediate descendant, and then selector 1 dot set class selector hey. And then I'll do rule 1 dot set property font. Font is going to just be a new identifier value of bold. I don't know. And then let's set another property of margin. Margin will have 3 pixel numeric values. Come on. Oops, it's an identifier value. That's probably why it doesn't have that overload. Pixels, let's just do 2, I'm getting lazy. So, anyway, the whole point of this test is just to make sure that my test thingy actually works. So let's go ahead and see if it works. Style sheet dot to debug string should be dot test ID whoa with a thing of that, with that, with that, open that, the font of bold, followed by a margin of 10px and 5px, followed by that. No idea if this is going to work, but it might. Oops, doesn't even compile. Probably because I'm missing a semicolon. Okay, so expected string to be that, but instead we got something that is completely wrong. So it's a good thing I did that. Why is it doing this to me? Ooh, because I used concat, not join. Derp. Expected string to be that, but instead got that. Why are you doing this to me? Let's check that out. In my style builder, we have our properties. Ooh, our properties are an IEnumerable of values. So we have to add in a string join. There we go. Closer. What are we missing? It looks like I have a space in between my values. That's a good thing, actually. So I'm going to go ahead and fix that on my test. And there's no colon. Oh, whoops, that's another problem with my test. Awesome. Okay, so now you guys can see that we have a data structure that we can use to construct an in-memory representation of our selectors. Now I know they don't actually do anything yet. These classes they implement the interfaces, but their only purpose is to print themselves right back out so we can test our tree grammar to make sure our tree grammar is understanding things properly. So let's write our first tree grammar test. Let's do basic, or how about simple class selector test. These are horrible, horrible test names, I know. So don't hate me too much, please. Okay, I'm going to copy out my parse CGS, but instead of parse CGS returning a common tree, I want parse CGS to return an iStyle sheet builder, or rather a style sheet builder. And then it's going to return that. Okay, so what am I doing here? I am instantiating my parser, and I'm passing in the input for that. Then I'm getting my tree. Now, the next thing I need to do is I need to instantiate my tree parser. So I'm going to go ahead and say tree parser equals new CGS tree, and I'm going to pass in a parse invocation to this. But my tree parser needs one more thing. See, what's going to happen is my tree parser is going to be invoking methods directly on the style sheet builder. So it needs a reference to the style sheet builder that it's supposed to build for. What I'm going to do is I'm going to create a constructor that takes in a builder. Or, no, actually, you know what? I'm going to say tree parser dot do things, and I'm going to pass in builder. Then I'm going to rename do things to build style sheet. And build style sheet is going to take in a builder, and I'm going to add that as a parameter to my CGS tree. Now you'll notice I have one more problem, is I don't actually go ahead and I'm not importing the project that has an iStyle sheet builder in it yet. So I can just hit Alt-Enter harder, and I can say reference CGS.base. And boom, I have that project referenced. So what does build style sheet do? It takes in an iStyle sheet builder, which it's going to set to a private iStyle sheet builder field. And then it's going to invoke style sheet. Now if you guys remember, this class is actually being generated by ANTLR. So when I go into style sheet, this is the code that ANTLR generated for my tree grammar. Which is cool because now that tree grammar can now reference my builder field directly within it. And so when it invokes style sheet, after it's done invoking style sheet builder should have been told by the tree grammar how to build the style sheet, which you'll see an example of that I already wrote out right here. Basically, all my tree grammar is going to do is it's going to invoke the methods on my style sheet builder like that. Okay, so now we jump into my tree grammar, and let's see about taking advantage of this. Well, in the spirit of red-green refactor, I just realized I forgot to actually write the test I'm supposed to be fixing. So let's go ahead and do that right now. I'm going to say parse CGS, let's do .test font blue, and then I'm going to say .to debug string .should be it should look like this, test font blue. Which is funny because the input and the output look the exact same, which is kind of what I was banking on. But I know that looks kind of like really, really anticlimactic, but I hope you guys understand what's going on. It's actually being converted into an in-memory representation right here, then being turned back out into a debug string, which I can use to test. So there I have a failing test. I'm going to go ahead and hide my successful tests. And so I can just focus on this. Remember, parse CGS, when I invoke this method, it's going to tell my style sheet builder, it's going to invoke all these methods on it. These methods are going to be responsible for building the in-memory object-oriented representation of my selectors, which are going to be used to actually, well, do work. But for now, my builders do nothing other than take input and then basically spit it back out when you invoke the toDebug string. That's so I can actually test to make sure that my tree grammar is invoking the right methods on my style sheet builders. So, again, it looks kind of odd, but That's what it's doing. Okay, so let's see about invoking those methods. If I jump back into my compiler, I have my CGS tree. Remember how I have that field right here? So let's see here. Okay, so a rule is going to have something special called a scope. Scopes in ANTLR are one of my most absolutely favorite features of the entire thing. I don't know if that sentence actually was proper English, but hopefully you got what I was saying. Scopes are awesome. Scopes allow me to... So let's say that I have a rule, and the rule goes into the selectors rule, and the selectors rule goes into a selector rule. Well, what if it did this like 5 times in a row? Like, let's say I have a rule that looks like this. .test, test2, test3, test4. So when I go into the rule, then I go into my selectors rule. My selectors rule then goes into multiple selector rules. Now, I need a way to reference data that is owned by the rule that is shared between each invocation of the selector rule. And I know this terminology is getting really confusing. It's getting confusing for me to keep track of because of the fact that ANTLR has rules, but also CSS has rules, so we have rules called rule, and so on and so on. But what we need to do is we need to get data back from the parent rule in ANTLR, and we do that with scopes. So what I'm going to do here is I'm going to create a scope with an style sheet builder called style builder, and that's going to be created every time a rule happens. Now you'll be wondering, well, wait a sec, this is going to cause a compiler error, isn't it? And it will, because notice how ANTLR just created this class with style sheet builder. I need to import the namespace that style sheet builder comes out of. But that's very easy to do. I can go up here to the top and I can do header. Anything I put in header will appear at the top of my file, and I can put in using cgs.base.abstract and using cgs.base.valueObjects. So now that error goes away because the oh derp. I'm going to go ahead and delete my console application. I don't need that anymore. I was just showing you guys that last week just for fun. Goodbye. Okay, now when I compile it works. So when I enter a rule, build a new scope with an style sheet builder. Then when I'm inside of here, what I need to do is I need to actually instantiate my style builder. So to do that, I have to do rule. This is how you reference something that's in a scope. Style builder equals, and then I gotta do underscore builder dot create style. I believe that's what the method looks like. Let me jump back into the, create style, and I believe I called that builder, and I did. Okay, so that's cool. Then, when we get into a class selector, what I want to do is I want to parse out the class selector and ident. Then I want to say, or hold on, when I get into a selector, what I want to do is I want to create a new scope again. Inside of this scope, I'm going to create an selector builder. Then, when I enter this rule, I want to say selector builder equals rule style builder dot create selector. So now every time I see a selector, I create a new selector builder from the parent rule's style builder. Then let's fill out my different selector types. So my class, actually I'm going to clean this code up. I'm just going to take this, I'm going to literally paste it in right there. This, I'm going to literally paste it in right there, and this, I'm going to literally paste in there. That has no effect. It just cleans up the code a little bit. Because each one of these alternatives is going to do something different. The first alternative is going to reach into the parent selector scope, get its selector builder, and invoke setClassSelector, and it's going to pass in ident.text. ID selector is going to do the same thing. Set ID selector, and element selector is going to say set element selector, but it's going to pass in a new element type value object instead of just a string. So those are my selector types. What about pseudo selectors? Well, that's easy. That's pretty easy to do. I can just go ahead and say parent selector selector builder dot set blah 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 pseudo selector to pseudo selector dot text. What about relationships? Well, with relationships, a descendant relationship will be parent selector selector builder dot, and this is going to be push descendant. And immediate descendant is going to be push immediate descendant. So far so good. Now the next thing I need to do is, if I go back into my tests, I believe I have a test that involves a selector, a compound selector. I think that's the actual term for it. Do I have an example of a compound selector anywhere? I don't. Okay, so let's go ahead and write another parser test. Let's back up for one quick second. Sorry, guys. We got to add one more thing to our grammar. What I want to be able to do is I want to be able to test compound selectors. So for example, let's say I wanted to select every single H1 with the class of test, and I wanted to give it the color of blue. So what will this look like? Well, it's a rule followed by a selector followed by a element selector H1 followed by nothing, actually. It's not going to be followed by an immediate descendant or anything. So instead I'm going to do compound, and then I'm going to do class selector test with a color of blue. So I'm going to introduce a new type of relationship. The new type of relationship is called compound. Hold on, something's going on here. Can I convert iStyleBuilder to iStyleSheetBuilder? I messed up my tree. How'd you guys let me mess up my tree? You guys broke it. Oh, whoops. This isn't an iStyleSheetBuilder. This is a iStyleBuilder. Here we go. Oh, shut up. Okay, so let's go ahead and do our compound selectors now. So it's failing. Rule relationship failed predicate is last token whitespace. So that actually makes this very easy to do. All I need to do is go back to my parser tests. I have a compound. I need to insert a new token called compound. Then down here, where I see if the relationship is greater or the relationship has a white space, if it's not a greater than symbol and it doesn't have a preceding white space, then I want to turn it into a compound. Wonderful. Okay, so now I have that being done properly. I can go back to my tree and I can work on my relationships again. I can say if we have a compound selector, then I push none. Okay, so I have my push descendants, immediate descendants, none, class selector, ID selector, element selector, pseudo selector. I think the last thing I need to do is I need to do my rules. And the rules are going to be fun, I guess. See, the values are going to be a little bit more difficult because we can have multiple values, things, stuff. So how's this going to work? What I'm going to do is I'm going to go up here. You see how I have this value plus? I'm going to actually change this to a rule called values. And I'm going to use the values rule to do value plus. And what I'm going to do here is I'm going to insert a new scope. And the scope is going to have a list of iValue values. When this rule starts, I want to say this equals new list iValue. Then at the end of this, what I want to do is, hold on. This is where things get complicated. No, what I'm going to do is I'm going to take declaration and I'm going to move it down here. And I'm not going to have a values rule. I'm just going to have a declaration rule. And it's going to match this. The declaration will have a scope of values. Now what I'm going to do is, because this declaration exposes values in its scope, my value rule is going to simply do declaration, so it's going to look for the parent declaration. It's going to yank out its values out of the scope. Then it's going to invoke the add method on the list, and it's going to pass in a new instantiation of the appropriate value. So in this case, this will be an identifier value with the text of ident.text. Okay, resource is going to be declaration values add new resource value with resource text. RGB color is going to be, oh wait, hold on. Resource, I'm not going to make a thing, I'm going to do that. RGB and RGBA colors are going to be a little bit tricky. And also, I don't know why I put in the syntax right there for that. RGB colors and RGBA colors, I'm going to move their implementation out into their own rules. So an RGB color is going to say declaration values add new color value. And it's going to pass in int.parse r.text G and B. G and B. Then my RGBA color is going to be, oh hold on, I think I totally messed up my RGBA color. Yeah, my RGBA color should have looked like this, with R equals number, G equals number, B equals number, A equals number, and then we're going to do that, but then we're also going to say, at the end of it, we're going to do float.parse a.text. Okay, color hash, I'm going to remove the extra rule for that. I don't really care about that very much. And then color hash is going to say color value dot from hash Remember, from hash is the method that we implemented inside of our color value method. From hash right there. From hash color hash dot text. Number is going to add a new number value. We're going to invoke float.parse on number.text, and we're going to pass in a number unit of none. Pixels is going to be the same thing, except for passing in a number unit of pixels. Percent is the same thing, except for we're passing in a value percent. And points is the same thing, except for we're doing it for points. Are the RGBA separated out for readability? No. The reason they're separated out is because I need to uniquely gather each one of the numbers and assign them to these special little variables right here, so I can reuse these variables in my action. Okay, looks like I still have an error. Reference to undefined rule RGB color on blah 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 line 76. It doesn't like line 76. Oh, it's probably because I have a semicolon right there. Holy crap, I made ANTLR very, very angry at me. Let's see here. Syntax error on CGS tree, line 78. Doesn't like line 78 very much. Oh, because I forgot the semicolon at the end of that. Okay, we're down to one more error. Syntax error, missing token on line 84. So it does, oops, because I have a semicolon right there. Okay, and it compiled. So let's see what happens when I run this test. Nothing, because this won't compile. Oh, whoops. This is actually going to be pixels, this is going to be percent, and this is going to be points. Oh, come on. Wow. Okay, so let's start at the top. It doesn't like values. That's because I forgot to scope values to my declaration. So in this case, I do declaration values. And next up, it doesn't like this because it cannot convert color value to I value. That's because I forgot to, on my color value class, I forgot to actually implement the value interface. Next up, number value does not have a constructor that contains one argument. Looks like I have a mismatch of, okay, I have a couple problems. First of all, this should be, yeah. Looks like I have some parenthesis mismatches. Yep, I have parenthesis mismatches. Next up, text, and no extension method called text is going to do it because it's dumb. Oh, I forgot to put the percent sign in front of that. Alright, it built. But it looks like okay, so it looks like our selectors may be working, but our properties are not. And do you know why that is? I filled up my list of values, but I never actually set them to anything. So let's go ahead and do that. That should be easy enough. I'm going to say for each var value in declaration values. Then I'm going to say rule style builder dot set property dot text followed by value. And I have a compilation error. What's wrong with you? Cannot convert I value. Oh, it's an I enumerable. That's why. Which means I don't need the for each loop. Hey, look at that. Our tree grammar is actually working. Okay, so just to back up a little bit before we go on break, and then actually after break we only have a few more minutes left anyway. So what's really going on here is we're using ANTLR to create a tree grammar, and then we're just sprinkling that tree grammar with straight up C# code. Now you will notice that this isn't actually technically C# code. When I do stuff like I have the money sign followed by an identifier like this, ANTLR does some pre-processing on that. It's not PHP either. And what it does, so for example, if I wanted to see this code right here, I can go into my code and look for, hey, there it is. So you can see that this code equals this code. It's the same bit of code. Now, ANTLR's marked it up a little bit. It's done stuff. It's looked at the scoping. It's gotten the right scope out of it and everything like that. But at the end of the day, stylebuilder.setProperty is still there, and then it extracts the text out of the token, passes that in as a parameter, and then it passes in another result of looking up the scopes. So yeah, ANTLR isn't terribly scary, and you'll see that, like for example, if I looked at my value, let's look at the value method. So there's a method called value, and look at what's inside of it. All of my values.adds. See all of this stuff? That's all just right here in the code. So you can even debug this code to kind of get an idea of what it's doing. Anyway, all right, so I'm going to go ahead and sneeze, and I'm going to go ahead and run outside for a few minutes, and I will be right back. Okay, and we're back. So let's go ahead and write some more tests to make sure that our tree grammar is actually working. But I'm getting pretty confident that it should be doing what it needs to do. So let's put in some more complicated tests. Actually, you know what? What I could do is I could just take all the tests we already wrote and rewrite them to make sure they work. Okay. So this, basically they should always equal the same thing, at least the way I wrote it, except for things like single line comments. This should look a little bit different actually. Single line comments, this one should look like test margin 0px, for example. This one should look like test margin 0px. This one should look like exactly what I put into it. Same with this one. See, fortunately, the way I wrote most of the CSS, it will actually match up exactly with how I made the output of my test harness. So it is kind of a coincidence that they work, that they should work anyway, except for the resource will be uncapitalized. Yes, we're talking about how we put together CGS. We've been putting it together for the last 3 weeks. And right now I'm working on the tree grammar, which fortunately I've already written a lot of tests that I can actually completely reuse, simply because the way I wrote the tests completely match up with how I wrote the test harness. So we already have a nice little test suite for us that we can use to run through pretty much all of the syntax that has been put together. So we'll run all these tests and watch them completely blow up my code. Alright, let's see what happens. And we got some major explosions. Ooh. What I'm going to do is I'm actually going to have the toDebug string. I'm going to have that part of the CGS method. Parse CGS is just going to return a string, and I'm going to return builder.toDebug string. Now let's see what happens. Awesome. So we got a lot of successes and a couple failures. So let's take a look at that. First thing, we're expected that, but got that. Oh, it looks like I just have an extra space that I need right there. Sweet. And I need an extra space right there, it looks like. And what's wrong with you? It's going to be 0.43 because of how it's converted. And then my colors are turned into RGBA values when they're turned into a string. This one needs a 0.5. So far I haven't actually run into a single bug with the actual code. It's just there's a small discrepancy between how my colors are computed. Oh, that's a whole lot of grain. We got 42 passing tests. Okay, so it seems that our tree grammar actually worked on pretty much the first try. Which, if that ever happens in code, it doesn't happen very often, but when it does, you start to get really nervous about it, because working on the first try isn't usually means that you're missing something. So what could I possibly throw at my tree parser that I haven't thrown at it already? I have child selectors, pseudo selectors, combined selectors, multiple selectors. I have, what kind of values do I have? I have resource values, percent values, point values, pixel values, numeric values. Pretty much have everything. One of the crazy the crazy selector I wrote last night actually used a sibling selector, which I am not implementing in CGS. This currently won't work with sibling selectors. nor will it work with attribute selectors. I mean, can anybody think of anything else to throw at this? Actually, hold on. I don't think any of my tests... No, none of my tests have multiple properties. Let's go ahead and test that. Let's do multiple properties test. So font blue, color 12 pt, margin left 5 pixels, background resource bleh.png 140 pixels. Let's see if this works. No, works just fine. Well, yeah. I don't know. So this will style UIs. Well, no, this is going to be styling GUI skins. But I'm pretty happy with how things are turning out. I mean, let's do one more crazy thing. I think we have time for one more crazy thing. Let's add a new feature to CGS. A feature that was actually already added into the real CGS but hasn't been implemented yet. No, this isn't like for like Lua. This is for styling skins only. So this is for making a user interface with the GUI skins. Let's go ahead and add in nested rules. What do I mean by nested rules? Nested rule in CSS, well, it actually isn't in CSS, but it's in many of the CSS languages, CSS-like languages. A nested rule looks something like that. So let's toss in a couple nested rules tests. So I'll do another nested rule. This other nested rule is going to have that with an li pound stuff. And then let's do a more complicated one where we have another nested rule inside of it where we have a bleh with a font of bold and then an ID of margin left 20 pixels. Alrighty, so this should be fun. So what should this look like? Well, this should be a rule with a selector, with a class selector of test, followed by another nested rule, which should be a rule followed by a selector. Oops, I did it again, didn't I? Followed by a selector, followed by a class selector of whoa. This should have a property of color blue. This should have a property of margin left 5. Okay, what is this going to look like? Well, this is going to be a little bit more complicated. We'll have a class selector of whoa with a pseudo selector. How did I even test pseudo selectors before? You know, it would help if I could spell that word consistently. I know I test pseudo selectors somewhere around here. Oops, I'm in the parser tests. What? I could have swore I tested one. Nested elements pseudo basic properties. But that doesn't have any... Oh, that does have one. Derp. It just says hover. Okay, sweet. So that means this is going to be class selector whoa with the pseudo selector of hover, followed by a descendant. Followed by an element selector type of li, followed by a compound, followed by a ID selector of stuff. Okay, so that's what that should be. What should this be? Wow, this is going to be a really hard thing to write a test for manually. You know what? I'm going to wait for this particular test. Okay, what happens when I do my nested rules 1? I get a failure. Which is good, because I wasn't expecting something that I haven't implemented to work. And yes, that has happened in the past, where you expect something that you didn't actually explicitly implement to not work, but then it does work, and then you get really confused, and then the world ends. Okay, so how are we going to implement nested rules? Well, let's see here. What we need to do is inside of our rule, we need... This is going to be difficult. We need to match a declaration, or we need to match a rule. So we can do declaration, or if it starts with a open curly, then oh great, we need one of those little fancy little doohickeys here, don't we? I can't remember what those fancy little doohickeys are called. Give me 1 second while I refer to the documentation. Because documentation is always good to have on hand, because you will inevitably forget some stuff. I wrote this stuff so long ago that I forgot how I actually implemented this. Alright, what do we need here? I know the word of the thing that we need, but I can't remember what it is. We need to look at ANTLR grammars. We need... It's not an action, is it? No, it's a predicate of some sort. Let me look up the index for this. P. Predicate. Predicates. We need a semantic predicate. Alters predictions function parameter. But we need a semantic predicate without a rule. Validating semantic predicates. No, we don't need a semantic predicate. That's the one that we already used. We need a syntactic predicate, maybe? Sorry about this, I just have to re-familiarize myself with what I'm looking at. Yeah, because we need to backtrack for implementing this properly. Let's just throw some code at the wall and see what happens. I think it looks something like we need selectors, we need to match selectors, And if we find a selector, if we match selectors followed by an open curly, that means we found another rule. And if we found another rule, then we want to jump back into rule in a nested fashion, I think. Hey, look. Well, it kind of works. At least it doesn't throw an ANTLR error. Now we're missing something. We need our subrules to... Okay, so rules plus equals. And then I'll put in my subrules first. Oops, we have an error. Reference to undefined rule rules. Oh, derp. No. Yes. No. Maybe. And I broke everything. Okay, how did I do that? Whoops. That's because I want this to be 0 to many rules. Hey guys, look at that. We have a nested rule. Isn't that magic? Okay, the only thing that I'm missing is that I messed up my my actual test. My test shouldn't have that semicolon there, or my colon there. Sweet. Okay, so now we have these two, which how did I mess this one up? I got it, ooh, I actually got it spot on. I wrote an entire AST by hand and I got it spot on with what the output should have been. So now we have one more. And this one was the one I just absolutely gave up on because it's too long. Let me just copy and paste what it should be right into the test and then look over it by hand and make sure that it's doing what I want it to do. Yeah, that looks about right. Alright, so now we have nested rules and in our parser, but not in our tree parser. So let's go ahead and write some tests for our tree parser to get that to work. Unfortunately, we don't actually have a way of doing compound rules yet with my builder. My iStyle builder, or sorry, my iStyle sheet builder has a create style, but it has no way of getting in a parent style. So there's no way for us to create a parent one. So I'll go ahead and do that. iStyle builder, create style, and then I'll pass in an iStyle builder as a parent. Okay, so what happens when we have a nested style? Well, when we have a nested style, how do I want to display this? I want to display it somehow. Let's worry about that later. Let's go back into our tree parser test and see actually how I want a nested rule to work or to look. So I'm going to jump back in here, and because I've already written some nested rule stuff, I'm going to take this and I'm going to dump it just like I did before. I'm just going to reuse these tests exactly how they are. But what should the output look like? Well, it should look like that, but then I have a nested rule inside of this, and how do I want that to display? Let's just have it display exactly how it's displaying on the thing. I'll have nested rules be printed at the end, or there we go. So that's what I want it to look like. Let's see what happens when I run this test. boom. We have a failure in my tree grammar. So, in the spirit of red-green refactor, let's go ahead and refactor so we get some nested action going here. Because next nested action is best action. So how did I print this out again? Did I put my rules at the beginning or the end? I think I put them after the selectors, if I'm not mistaken. Did I do that? I can't remember. I did do that. Okay, so rules come after the selectors. So, whoops, there we go. So here's a rule that happens. Okay, so what happens when a rule goes into another rule? Well, what we need to do is we need to be able to identify if there's a parent rule already active. Now, a way to do that is to what I'm going to do is inside I'm going to add another thing called members, and I'm going to say int rule level. Every time we enter a rule, I'm going to increment my rule level, and every time we exit a rule, I'm going to decrement my rule level. That way I can know if I am inside of a nested rule or not. So remember, there's now two overloads of create style. There's an overload that you can pass in a parent style, and there's an overload where you don't. So what I'm going to do is I'm going to say if builder create style, I'm going to say rule level is greater than 0. Whoops, no. Let's do this. If rule level is equals 0, then do that. Otherwise, we want to say rule style builder equals builder create style, and now we have a problem. How do we access the parent rules style builder? Because if we did rule style builder like this would actually pass a null and it wouldn't make any sense. We need to access the style builder of the rule that's above this rule. To do that, I can use the rule level, and I can use array syntax. I can say rule level -1. And I get that. Let's go ahead and see what the generated code looks like and make sure that I didn't completely mess everything up. Whoops, I completely messed everything up. Hold on. Whoops, it's backwards. I'm supposed to say rule at rule level -1 style builder. Did that fix it? Almost. Cannot resolve symbol element at? Seriously? What? What are you talking about? This is code that ANTLR generated. Why is it using It's very concerning. Because C# doesn't have a method called element at on the stack. Now link does if I were to import link, but even then it wouldn't really work because it's a lowercase element at, not an uppercase element at. So how can this be failing so miserably? Am I working with an older version of ANTLR that actually has a bug with it? Google time. ANTLR. Let's get this exact error. ANTLR Let's look at why ANTLR would do such a horrible thing to me. Targets. Let's see here. Codegen, templates, C#3. Let's look at C#3.stag or stg. Wow. They have element at straight up right in the string template for the code generation. There is no method called element at in C# because with the lowercase e. How could that have possibly been ever approved? What is this? It's a stack. It's just a normal C# stack. Okay, so do you know how we fix this stuff? We fix this by introducing a extension method. Stack extensions, and I'll go ahead and make this an internal static class. It'll be a public static t element at with a lowercase e, this stack t that, int index, return that, and then we'll just pass an element at to there, and then I'll tell resharper to ignore the inconsistent naming because I'm doing this on purpose, and then I'm going to include my extensions up here in my header. Yep, I fixed it. Okay, now I completely forgot what I was actually doing. Nested rules. What was I doing with nested rules? Yeah, what happens when I click on this button now? Object not set to a reference of a blah blah blah. Oh, derp. I know why that is. That's because I'm returning null for the overload that is supposed to be returning a style. Okay. So what I'm going to do instead, I'm going to go ahead and say I'm going to cast parent to a style builder. Parent, and then I'm going to say create child style, return. Creating a child style, all that's going to do is I'm going to have a private read-only list of style builder nested rules. Nested rules equals u. When I create a child style, I'll create a builder equals new style builder, add it to my nested rules, and then return it. Then when I do my toDebug string, I'm going to have my selectors followed by my properties followed by my nested rules. Which then I'm going to say nested rules.any. If there are any nested rules, then we want to do string.join space on nested rules select t.toDebug string. Now let's see, watch me blow everything up. Alright, we're still getting a null reference exception on this. So for some reason we're passing null in as the parent. For some reason. Ooh, I don't think I need that -1 there. Or do I need the -1 there? Wait, I have to invert that number, don't I? Because maybe I don't. I can't remember. It's too late. Let me see what happens when I press the button now. Hey, look, it works. Except for I forgot to put a semicolon in my test string. That's easy enough to fix. Sweet. Now this one is failing. Obviously it's failing because I didn't actually change the test to what I want it to be. What do I want it to be? I want it to pretty much be exactly this. Except for... No, actually I do want it to be exactly that, don't I? Oh, hey, look, it works. And then for this guy, what I want this guy to be is pretty much this, except for the properties will appear before the nested rules. Oh, great. What is color blue actually even attached to? I have no idea. Maybe it's on this rule? I don't know. Expected string to be this. Ooh, looks like we have a bug here with my... Hold on. Let's do some crazy debugging action here using comments. Okay, so... this is what we're getting back from CGS. Something is very wrong with it. Okay, so that's what we're getting back from CGS, but this is what we passed into it. I have no idea why ReSharper is putting in those extra curlies, and honestly it doesn't really bother me too much right now. I'd rather get this figured out. Okay, so that's what we passed in, that's what we got back. It looks like what's happening is every single nested selector is being appended or added to the same parent. Now I know for a fact that my parser is working because I already tested my parser. And if you look at this, we see that the rules are actually being indented properly. Yeah, the rules are being indented properly. What we're having right now is a problem with the tree grammar attaching all nested rules to the topmost parent, which isn't what we want. Ooh, that's because it's my extension method. It needs to be swapped. So it should actually be that.count minus index. That would make sense. Well, hey, look, it works. Okay, so how's everyone feeling? We got nested rules working, we got the tree grammar working, it's invoking the appropriate methods on my builder interfaces. We're going to be mapping it to GUI skins. That's going to be the last step. The first step is we need to build a parser. The second step is we need to build an in-memory representation of our style sheets, which we'll do next week. We have the builders in place, but we don't have the builders actually building anything. Then after our builders get to actually building something, then we'll write the code that maps the CGS properties to the Unity properties. Does that make sense? I'm trying to keep Unity as far away from CGS as possible. Sure, this is just straight up C# code. Wherever you can dump C# code, you can use this. As long as you write the code that maps the internal representation of CGS to whatever game engine you want. Okay, but yeah, next week is going to be a lot. It's going to get into some crazy stuff because we won't be starting off with ANTLR next week. We'll be starting off with how do we actually create a selector that is capable of knowing if a particular element is selected. Then we'll take that code and hook it into our style sheet builders. But yeah, I'm pretty happy with how our tests are turning out. I felt very confident in writing the nested rules code, even though it's pretty crazy the way it looks and the way it works. But I felt pretty confident adding this in because I have so many tests that go ahead and make sure that I didn't break anything in the process. I think I have a pretty comprehensive test suite so far. It could be made better, and if we ever run into an error with CGS, we can always just add another test for it and use that as a mechanism for fixing it, while making sure we don't break anything else. Okay, so I think that just about wraps everything up. So to all you future people, I'll see you next week.